Hello all, welcome to Deep Learning series. In this video, I am going to explain the basics of DL, and later episodes we can extend the topics to understand and program with DL models. Let's get into it. Have you ever wondered how your phone recognizes your face, and how YouTube recommends videos, and how ChatGPT understands the text, or how a robot can identify objects? Behind many of these technologies, there is a one powerful idea: deep learning. In this video, we will understand deep learning in the simplest way. Before we define deep learning, imagine a small child learning to identify a dog. So we do not teach the child every rule, like if the animal has four legs, a tail, two ears, and barks, then it is a dog. Instead, we show many examples. One dog may be black, another may be white, one may be small, another may be large, and another may be running. Slowly, the child starts recognizing the pattern. So deep learning is also work on the same principle. We give the computer many examples, and instead of manually telling every rule, the model learns patterns from the data. Now, where does deep learning fit? Think of three circles. So let's say here we have the first circle. The biggest circle is AI, so which is artificial intelligence. It is the broad idea of making machines perform tasks that normally need human intelligence. Inside AI, we have a machine learning. So you draw one more circle inside the AI. Let's call it as a machine learning, where the machine learns from the data instead of being programmed with a fixed rules. And inside a machine learning, we have another circle which is a deep learning. So deep learning is not separate from machine learning. It is a special and powerful part of the machine learning. And IBM explains this hierarchy as an AI containing machine learning and machine learning containing a deep learning. So that's the structure. The main idea of deep learning is this: it uses artificial neural networks with many layers. These networks are inspired by the structures of the human brain. So, but they are not exactly the same as the brain. They are mathematically models made of connecting units called neurons, or in deep learning terminology, we can call it as a nodes. Now you can look at the slide. We given an image of a dog as an input. So this is an image. We feed to the deep learning model. So we have a deep learning model, and this dog picture or photo we just given as an input. So now the model should predict whether it is dog or something else. But the computer does not see the dog like we see it. It sees numbers, pixel values, and every pixel has values of colors and brightness. So for the computer, the image is just a huge table of numbers. So in the first layer, if you take the multiple layers we have, so like if the model is too heavy, then we have multiple layers. And similarly here also you can see at the first layer, the model may learn very simple patterns like edges, lines, corners, and in the next layer when it is training, it combines those edges to understand the shapes. And further, if you create more layers, like in the deeper layers, it may understand eyes, ears, nose, legs, and the body structure. Finally, after many layers, it can say, yeah, this image is likely a dog. The most important point is this: deep learning learns features automatically. In traditional programming, human write the rules. In traditional machine learning, even human often select the features. But in deep learning, the model learns the important features by itself from the examples. So whenever you hear deep learning, remember this simple line: deep learning is a machine learning method. So when neural networks learn patterns automatically from the data, layer by layer. That is the foundation of image recognition, speech recognition, self-driving cars, ChatGPT-like large language models, robotics vision, medical image analysis, and many more modern AI systems. Now let's compare traditional machine learning and deep learning with very simple example. Suppose we want to build a system that identifies whether an image contains a dog or not. In traditional machine learning, the first step is usually feature engineering. That means human must decide what information is important. We may tell the model look at color, size, texture, shape, brightness and maybe some edge patterns. For example, we may say dog usually have four legs and it may have a tail and have certain face shape. Then we convert these details into numbers and give them to the machine learning algorithm. This approach can work well for many problems, especially when the data is small. So here it is important when the data is small, structured and easy to describe. For example, predicting a house prices. So we are living in a country, so we wanted to predict the prices for the next years. Then we can use some features like number of rooms, area, location, and age of the building. In such cases, traditional machine learning can be very useful. But now, think about images, audio, video, and natural language. These are much more complex. A dog is one image may be standing, so in another image, it may be sleeping. In one image, only the face is visible. In another image, the dog may be behind a chair. Lighting may change, background may change, size may change, color may change. So the big question is, can human manually write all possible features for all possible dog images? That is very difficult. This is where deep learning become powerful. Deep learning says, do not manually give me a color, texture, shape and size. Just give me more examples. I will learn the useful patterns myself. That's the main difference. So traditional machine learning depends more on human feature engineering, but deep learning performs automatic feature learning, also called representation learning. So we will give the raw input. So you can see the raw images. So of course it's in pixel. It has some information about the pixel like RGB values or the grayscale values, something like this. For example, if it is a speech, raw input means sound waves. For text, raw input means words or tokens. Then the model passes this input through many layers and learn useful patterns automatically. This is why deep learning is very successful in areas like computer vision, speech recognition, language translations, robotics, medical imaging, and generative AI, etc. But here is one important point: deep learning is powerful, but it is not magic. Deep learning usually needs a lot of data, strong computing power. So our normal laptops won't take, like, we need a GPUs, the more computation power we require to solve the complex deep learning problem, and we need a careful training. It can also be harder to explain compared to simpler machine learning models. So we should not say deep learning is always better. Instead, we should say deep learning is especially powerful when the data is large, complex, and structured. So the difference is very simple. In traditional machine learning, human create the features and the model learns from those features. In deep learning, the model learns the features and the final tasks together. Okay. Now, if you understand the basic concept and the difference of machine learning and deep learning, let's take a quiz. So here I posed two questions. The question number one is, what is deep learning? So option A subset of machine learning that uses multi-layer neural networks. B, a programming language for AI. C, a database used to store images. And D, a fixed rule system that never learns from data. Question number two, what is the main difference between traditional machine learning and deep learning? Option A, traditional machine learning learns features automatically while the deep learning uses handwritten rules. Option B, deep learning often learns features automatically from the raw data, while a traditional machine learning usually needs a manual feature engineering. C, there is no difference between them. Option D, deep learning only works for calculators and spreadsheets. Please comment your answers in the comment session, so I will post you the answers in the next video. And in the next lecture, we will go one level deeper and understand what an artificial neural network is, and what neurons are, and what layers are, and how data flow from input to output. Thanks for watching till here. Have a good day.